So similar to what we were doing last class, we're going to do a couple of do-nows. So for the first one, we want to take the cubed root of this whole thing. So remember, we're going to do the cubed root of each piece. So the cubed root of 27, we know is 3. The cubed root of x to the 7th, we're going to rewrite x to the 7th with a multiple of 3. So we can rewrite that as the cubed root of x to the 6th, and then we have the cubed root of x left over. So on the outside, I can take that 6 and divide it by 3. So I have x squared. And on the inside, I'm going to have the cubed root of x. Y to the 3rd is already a multiple of 3. So 3 divided by 3 is 1. So y on the outside. Z squared is not higher than the index of 3, so that has to stay on the inside. Okay, with the second one, 32, we're going to break down. So remember that, negatives are fine when we have odd indexes. So we're just going to have a negative on the outside. If I break 32 down, I can break that into 16 and 2, 4 and 4, 2 and 2, 2 and 2. So we need 3 of the same number. So we can't use 32, we can't use 16, and we can't use the 4s since they break down further. So I'm looking for 3 of the same number. So I have 3 2s. So that's going to go on the outside. And then I have this 2 and this 2 left over. So on the inside, I'm going to have a 4. Now the f is to the 6, which is a multiple of 3. So 6 divided by 3 is going to give me f squared. G to the 5th, I can't divide 5 by 3 evenly, so I bring it down to g to the 3rd. So 3 divided by 3 is 1g, and I have 2 left over. And then h squared is just going to stay on the inside since it's less than the index. Okay, so 162, we're going to do the same thing. So 162, I'm going to break down. So 9 and 18 work. 9 will be 3 and 3. 18 will be 9 and 2. And 9 will be 3 and 3. Because I'm looking for the 4th root, I'm looking for 4 of the same number. So I can't use 162, I can't use 9, I can't use 18, I can't use 9. So I have 4 of the same number here. So I have a 3 on the outside. And then on the inside, that should be a 4 here. I'm going to have left over a 2. And that 2 is left over. So a to the 3rd, 3 is less than 4, so that has to stay inside. B to the 8th, 8 can be divided by 4, so I'm going to have b squared on the outside. And now c to the 11th, I can't divide 11 with 4, so I'm looking for a multiple of 4. So my closest multiple of 4 without going over 11 is 8. So 8 divided by 4 is 2, and then I have 3 left. And for the last one, 128, I'm going to break 128 down. So 4 and 32, 2 and 2, 8 and 4, 4 and 2, 2 and 2, 2 and 2. So I can't use 128 or 4 or 32 or 8 or 4. So I'm going to look for groups of 5 now. So 1, 2, 3. 1, 2, 3, 4, 5. So I have 5 2s. So I'm going to take out a negative 2. On the inside, I'm left with this 2 and this 2. So I have a 4 on the inside. X to the 4th is less than the index, so it stays inside. 10 divided by 5 is 2, so y squared. 17 divided by 5 is not going in evenly, so we bring it down to 15. 15 divided by 5 is 3. And then we're left with 2 on the inside. Okay, so what we're doing today is operations with radical expressions. We've done this in the past, so it's more of a review than anything new. We're going to add, subtract, multiply, divide, and simplify. and then we're also going to rationalize denominators of fractions. When you multiply radical expressions, you need to have the same index. So the index is the little number. So we're focusing on this piece right here. So since the square root of 2 times the square root of 3, they both have little indexes of 2, even though they're not listed, you can multiply them together and get the square root of 6. The cubed root of 4 and the cubed root of 5 is going to give you the cubed root of 20. Okay, so as long as your index is the same, we can multiply them. So can we multiply these expressions? Okay, so this one, no, since the indexes are different. This one, yes, the indexes are the same. This one, no, my indexes are different. And this one, yes, my indexes are the same. So if I were to multiply the yeses together, this would give me the cubed root of negative 8, which I can simplify and get negative 2. This is going to give me the fifth root of 10, and I can't simplify that any further. So for these examples, we're going to multiply these together and then simplify our answer. Now you can simplify things first if you want to and then multiply at the end. There's more than one way to do the same problem. For our purposes, I'm going to teach you how to do it by multiplying everything first. So we're going to multiply the 2 and the 4. So since the indexes are the same, we can multiply these. So this is going to give me the square root of 8. And then x cubed and x cubed is going to give me x to the 6th. Once I have this, I'm breaking it down like we did last class. So the square root of 8 is going to be 2 radical 2. And x to the 6th, I can divide it by 2, and I get x cubed. Okay, for this one, same thing, 2 times 5 times 10. So this is going to give me the square root of 100. X cubed, x squared gives me x to the 8th. Y cubed, and y is going to give me y to the 5th. So now I'm just going to break that down. So square root of 100 is 10. Square root of x to the 8th is x to the 4th. Square root of y to the 5th. I can't divide 5 by 2, so I'm going to take it down to y to the 4th. Divide it by 2, I get 2. And then I have 1y left over. Okay, so if we look at a couple more, again, you can break each one down if you would like. If you want to break down 27ab cubed first, and then break down 5a to the 4th b, and then multiply your answers together, you will get the same final answer. So I'm going to multiply my numbers together. So this is going to give me 135, and then I have a to the 5th, b to the 4th. So 135, if we break it down with our trees, 5 and 27, 9 and 3, 3 and 3. I have a pair of 3s, and I have a 5 and a 3 left over. So this is going to give me a 3 on the outside. A to the 5th is going to become a squared with an a left over. B to the 4th is b squared. On the inside, this 5 and 3 become 15, and then I had my a left over. Okay, and the last one, 16 and 2, is going to give me 32, x to the 10th. So 32 is going to be 4 radical 2. So I have 4x to the 5th, radical 2. When you're dividing radicals, so we're going to look here, you have to have the same index. So square root of 2 over square root of 3, we can rewrite that as the square root of 2/3. The square root of the cubed root of 4 and the cubed root of 5 can be rewritten as the cubed root of 4/5. So if I had the square root of 10 over the square root of 5, I can make this the square root of 10 over 5, which would end up being the square root of 2. So sometimes writing them as a giant square root instead of the top and the bottom will make simplifying easier. So if we look at these examples, we know how to rationalize denominators by multiplying by the radicals to get rid of them. But if we rewrite them as giant radicals, we can simplify using our exponent rules. So the square root of 54 x cubed y cubed over the square root of 2x y squared, we can rewrite this as like a giant square root. So 54x cubed y cubed over 2xy squared. So now we're just going to simplify these exponents. So 54 over 2 is 27. X cubed over x is going to be x squared because we're subtracting. Y cubed over y squared is going to be y. So now that we have one radical, we can now break that down. So square root of 27 is 3 root 3. X squared, the square root of x squared is x. And then the square root of y stays square root of y. So I have 3y. So it's the same concepts from last class, but now we're just kind of doing another thing first. Okay, so let's do the same thing here. 9, and then we have a giant radical. So 48x to the 8th over 2x cubed. So this is going to be 9. 48 over 2 is going to give me 24. And then I have x to the 5th. So 24 is going to be, so I have a 9 on the outside. I'm multiplying that with the square root of 24, which is going to be 2x squared radical 6x. So I'm going to multiply the 9 and the 2. So I have 18x squared radical 6x. Okay, and the last one, it's cube roots, but it's the same idea. Because they're both cube roots on the top and the bottom, I can write this as a giant cube root. So 162y to the 5th over 3y squared. So 162 over 3 is going to give me the cubed root of 54. And then I have y cubed. So 54, we're going to break down. 9 and 6, 3 and 3, 3 and 2. We're looking for groups of 3, so it's 3 on the outside and cubed root of 2 on the inside. So I'm going to have 3. And then y cubed, the cubed root of y cubed is y. And then we're left with the cubed root of 2.